All right, the greatest common factor, CR10. So we're going to talk about the greatest common factor because they help us to factor polynomials. And so the greatest common factor of, let's say, 16 and 20 is the biggest number that goes into both numbers. So if you think about like 16 is, here's your factors of 16. 1 and 8, 1 times 8, I'm sorry, 1 times 16 is 16. 2 and 8, 4 and 4. Those are all the factors of 16. 20, factors of 20. 1 times 20 is 20. 2 times 10 is 20. 4 times 5 is 20. There's all the factors of 20. The biggest common factor of those two is 4, right? That's the biggest number that is a common factor of both of those. Well, this gets kind of tricky when you have big numbers. Like, what's the GCF of 88 and 484? And you're probably like me, and you're like, I have no freaking clue, and I don't really care to list every factor. It's going to take me forever. So there's a good way to do that. And what you do is you factor it into a product of all its prime numbers. So for example, 88, I know 88, factors of 88 are 8 and 11, right? But 8 I can go further with. 8 is 2 times 2 times 2. 11 is prime. I can't go any further than that. 484. Well, 4 and 121 is 484. Well, 4 is 2 and 2. 121 is 11 and 11. There it is. 2, 2, 11, and 11. So the greatest common factor is what you do is you take one of each that they have in common. They both have a 2 in common. They have another 2 in common. And they both have an 11 in common. So the greatest common factor ends up being the product of their common factors. 2 times 2 times 11. 4 times 11 is 44. That's the greatest common factor of 88 and 484. And you could do it with three numbers as well. You could factor 100. 100 is 10 times 10, or 2 times 5 times 2 times 5. So 2, 2, 5, and 5, that's 100. 14, 2, and 7 are its prime factors. 35, 5, and 7. And I'm looking at these, I'm like, gosh, they don't all have a 2. They don't all have a 5, and they don't all have a 7. So what's the greatest common factor? Well, it's actually 1. Because 1 times all of these, 1's the only thing they actually have in common. So they have nothing in common. The greatest common factor is just 1. Kind of annoying, right? Let's do it with variables now. So 30, x to the 4th. 5 and 6 is 30, but 6 is 2 and 3. So 2 times 3 times 5. Then I've got 4 x's. 130 x to the 6th. Well, 130 is 13 times 10. 10 is 2 and 5. So 10 and 13. 13 is a prime. 1, 2, 3, 4, 5, 6 x's. And then 60 x to the 9th. Well, 60 is 15 and 4. 4 is 2 times 2. 15 is 3 times 5. All right, so the greatest common factor. They all have a 2. And it looks like they don't all have a 3, but they all have a 5. They all have a 5. And then how many x's do they have in common? It looks like the most x's is 4. They do have 4 x's in common. So the greatest common factor would be 10x to the fourth for those two. All right, let's keep going here. How about 60ab to the third? So 60 is 4 times 15. Here's our 4, there's our 15. And then 1a and 3 b's. Negative 30a. So we had negative 1 times 3 times 10. So let me do 10, 2, 3, 5. There we go. And then an a. I got 80b. That's 8 times 10. Here's my 8. There's my 10, 2 and 5, and then I got a b. Negative 70b. Negative 7 times 10, so negative 1 times 2 times 5 times 7, and then a b. Well, let's see. They all have the greatest common factor. So the greatest common factor, it looks like they all have a 2. They all have a 5. They do not all have an A. They do not all have a B. So it looks like my greatest common factor is just 10. All right, why don't you guys try these? So our GCF here ends up being 1, 2, 3 2's they have in common, and then at most 3 x's. So the greatest common factor, 8x to the third. Go ahead and check this one as well. Go ahead and write this out and check it. Greatest common factor of these 3. Greatest common factor here is 1. Notice they don't have anything in common, so you just put that 1 in front of all these. They just have a 1 in common. That's it. Well, let's go ahead and factor out, if you're factoring 30x plus 42, you say, well, what's the greatest common factor of 30x and 42? And you say, well, the greatest common factor is a 6. So what would be left over? Well, 30x divided by 6 is 5x, and 42 divided by 6 is 7. And that's how you would factor that. And make sure, go ahead and check it, right? Check it by distributing it back, and make sure you get the same thing that you started with. 30x plus 42, there you go, yep. So there's our factorization. Let's go ahead and factor 28x plus 70 and have you guys try that. So let's say you said the greatest common factor of 28 and 70 is 7. It's actually not, because notice 4 and 10 both have a common factor of 2. So you can actually take a 2 out as well. So the greatest common factor is actually 14 on this one, right? So if you have 28x plus 70, their greatest common factor is 14, and you're left with 2x plus 5. So that can be kind of tricky. I would have done the same thing probably, is take a 7 out, but hopefully you see that you can go further with the 4 and the 10 there on that one. So the greatest common factor, there's 14, what you want to take out. Let's do this one. If you have a negative 1 in front, you want to take a negative out. And notice both of these have an x as well. So I'm going to take a negative 3x out, and I would be left with x plus 7. And go ahead and distribute that back and check it. See how when you distribute it back, it gives you the original. Now, this one, 63x cubed plus 21x squared, notice the leading here is a positive, so I don't need to take out a negative. So I'm just looking at the 63 and the 21, and the greatest common factor is 21, and I can take out at most 2 x's. And I would be left with 3, because 3 times 21 is 63, x plus 1. Again, make sure you always check it. Check that you did that right by distributing it back, and you get 63x cubed plus 21x squared. That's what you started with, so you're good to go. All right, you guys punch this one into the chat there. So the greatest common factor of those two is negative 18x squared, and you'd be left with 3x plus 1. Again, always make sure you check it by distributing it back and making sure you have what you started with. There's your negative 54x cubed. There's your negative 18x squared. So good to go. All right, let's move on here and let's factor. Now I have 3 terms, but notice they all have an x. So I can take an x out of each of those, and I'd be left with 6 x's now and 3 x's and just a 1. And then make sure you distribute it back and see that you'd get the same thing. This one similarly, except I'm going to take out, I can take a 4 out of each of these. I'd be left with x squared minus 3x plus 8. If you look at this next one, what would you factor out of that one? If you factor an 8 out of each of those, you'll be left with that x squared plus 3x plus 11 like Nick has there. All right, notice this first term is a negative, so I'm going to factor out a negative, and all those will go into 8. So I'm going to take a negative 8 out. Each of them have at least one x, so I'm going to take an x out. And each of them have at least one y, so I'm going to take a y out. So I'd be left with xy squared plus 2. I've already taken the x out and a y. And then negative 48xy divided by negative 8xy gives me 6. I've taken an x out, I've taken a y out. So xy squared plus 2y plus 6. That would be that one. Well, you guys try that one. Punch it into the chat. Good. All right, let's keep going here. This one's kind of interesting. You have 2 terms here. Here's one term minus, and here's a second term. And notice both of those terms have an x plus 19 in common. So what you're going to do is you're going to take an entire x plus 19 out. So it's kind of like factoring this. You know, if I was taking a y out, I'd be left with x minus 16. But in this case, I'm taking an x plus 19 out. I'm left with x minus 16 in parentheses. Okay. So x plus 19, x minus 16. Let's do another one like that. This one they both have an x plus 5, 2x plus 5. So I take a 2x plus 5 out, and I'm left with 8x plus, and there's a plus 1 right there. 2x plus 5 times 8x plus 1. Coefficient there in front of that 2x minus 5. So then the question becomes, what about this one? I got 2 of these x plus 5s. In fact, let me write it out this way. X plus 5 minus 11, x plus 5. I have an x plus 5. I'm going to factor out an x plus 5. And I'm left with one of these x plus 5s minus the 11. So this ends up being x plus 5, and then 5 minus 11, x minus 6. Well, that leads us to what's called factoring by grouping. So what you do when you're factoring by grouping is, this happens sometimes when you have 4 terms. So notice I have 1, 2, 3, 4 terms, right? I have 4 terms here. And what I'm going to do is I'm just going to let me look at just the first 2 for a minute, x cubed and x squared. I can take an x squared out of both of those. Now let me look at these next 2 terms. I can take a 15 out of both of those. And now notice I'm left with 2 terms, and they both have and x plus 1. So I take an x plus 1 out, and I'm left with x squared plus 15. And that's called factoring by grouping. Factoring by grouping. Okay, let's do one more, and then I'll have you guys try one, factoring by grouping. So here's another one. Look at the first two. I can take a 3x squared out. Look at the next two. I can take a 4 out. And now I have two terms, and they both have an x minus 5. And I'm left with a 3x squared plus 4. By the way, if you were foiling those back, you would get the original, right? So let's go ahead and have you guys try this one, factored by grouping. So there you go. If you want to check your work there, you should get x minus 2 times x squared plus 17. Thanks for watching. See you guys next time.